Hello friends, I welcome you all to my channel. This video is part of the playlist uh, NCERT solving NCERT fingertips mathematics problem of class 12. This video is the second part of the previous video on solving problems of integrals from the book Objective NCERT at your fingertips. It comes in one volume for both class 11 and 12. If you have not watched the previous video, part 1, I suggest you to please watch that video where I have solved few problems from the chapter integrals. In this part 2, I will solve another set of 5 problems from the book. So let's get started. Okay. So on the left hand side, as the previous video, I've taken uh, I have the reference of all the standard elementary integrals and some basic standard integral results, along with some trigonometric identities and functions identities, which will be frequently used in solving integrals having trigonometric functions as a reference. On the right hand side, I will solve the problems. Now, in the previous video, I forgot to mention the 3 special form of integration. As you can see, I have written down the 3 special form, which is very basic, and I hope you are all familiar with these 3 basic 3 special form of integration and the very basic properties of indefinite integrals. So I have written down you can see the properties of indefinite integrals. If you wish, you can take a snapshot of these properties and the 3 special form of integration. Okay, so let's start solving the problems. The first problem is integral of e to the power x log a plus e to the power a log x plus e to the power a log a dx. Now, I can see all the terms are e to the power, and sorry, my microphone again fell off. If I use the properties of logarithm, that is, we have a property that a to the power log base a b equals to b. If we use this property, then we get this expression given integral becomes a to the power x plus x to the power a plus a to the power a. A must be some constant, and it is assumed that a is greater than 0. So now we can separate out the terms as separate integrals, and we have this. The last term is a constant. So a to the power x, the integral of a to the power x is a to the power x divided by log e a, and this is x to the power a, so we can use the integral of x to the power n, and this becomes x to the power a plus 1 divided by a plus 1, and this is a constant, and it becomes x into a to the power a and the constant of integration. If you find any error in my solution, then please do let me know, because I am solving this problem for the first time and I don't know the solution and I don't know the answer. So I will highly appreciate if you see any error in any step of the solution, and let me know in the comment section. Okay, let's do the next problem. This is integral of 8 to the power 1 plus x plus 4 to the power 1 minus x divided by 2 to the power x and dx. Okay, so we can see that we have the term 2 to the power x in various places, because if we rewrite the terms a to the power 1 plus x with the base 2, let's do it. This is equals to 2 to the power 3 1 plus x plus 2 to the power 2 1 minus x divided by 2 to the power x. Okay, so let's see if we can further simplify it to make it more, we can reduce it further. So this is mm, this is 8 into 2 to the power 3x divided by 2 to the power x plus 4 into 2 to the power divided by 2 to the power this. Okay, so if we take substitute 2 to the power x as t, will it help? 2 to the power 2x. 3x plus minus 2x. Oh, this becomes 2 to the power minus 2x. 2 to the power 3x. 2 to the power 3x. Okay, so this becomes, if we separate out, if we do further simplification, we get this is 8 into 2 to the power 2x, and this becomes 4 into 2 to the power minus 3x. Okay. So this becomes dx plus 4 2 to the power minus 3x dx. Now we can use the standard integral, standard result of integral of 2 to the power x. What is integral of 2 to the power x? This is 2 to the power x divided by log e 2. Okay, so this becomes, now over here to find the integral of 2 to the power 2x, we have to use the special form, this one, the first form, the first special form, the first one. So we have to divide by 2. So this becomes 8 2 to the power 2x divided by log e 2 and also multiplied by 2, because of there is 2x, because the power is 2x, not x. So we have to divide by 2. Similarly, over here it will become 4 into 2 to the power minus 3x divided by log a2 and minus 3. So this becomes, and plus constant of integration. So this becomes 4 uh, mm, 2 to the power 2x divided by log a2 and minus 4 2 to the power minus 3x by log a2 plus c. Now we can do further simplification, it is not required. We can take out 4 by log e2 as common factor, and it becomes 2 to the power 2x minus 2 to the power minus 3x. I hope, no, what happened? This is 4 and this is minus 4 by 3. So it will be, if we take common 4, we will have this by 3. Okay. So let's do the next problem. The next problem is, this is a very standard problem, some power of sin x and cos x. Now to solve this kind of problem where we have sin x and cos x, product of sin x and cos x, and their powers, the odd powers, the standard procedure is to, if you have the power of sin x is odd, so we can substitute cos x equals to t. This will imply minus sin x dx equals to dt. Now if we substitute if we now do the substitution, we get so minus sin x dx equals to dt. So from sin cube x we can take out, we can take sin x and we have dx, and we are left with sin square x and cos cube x dx. Now this is minus dt, and sin square x is 1 minus cos square x, which is 1 minus t square, and cos x is t. So this becomes minus integral of t 1 minus t square dt, and so this becomes minus dt plus t cube dt. This is minus t square by 2 plus t4 by 4 plus c. We have substituted cos x equals to t, so it becomes minus cos square x by 2 plus cos to the power 4x by 4 plus c. I hope I did not make any mistake. Please check it. If I do any mistake in any steps, please do let me know in the comment section. Okay, let's do the next problem. The next problem is again okay, So we have powers of sec x to the power 4 by 3 and cosec to the power 3 by dx. Now, okay, so if we can see that we have cosec x 4 by 3 square. Now, cosec x, sec x. What is the differentiation of sec x? Sec x tan x. Cosec x, derivative of cosec x is minus cosec x cot x. One approach will be to convert it to sin x and cos x, and let's see what happens if we convert this to sin x and cos x. What do we get? Because this becomes cos x into sine 4 by 3x square. Okay. Now, what should we substitute? A general strategy when we have an integral of the form like this, sine to the power nx and cos to the power cos x to the power m. What we generally one standard way is to write in the numerator one as sine square plus cos square x, sine square x plus cos square x, and then we split the term and some powers will cancel out, and then we can do substitute either sin x cos x equals to t or sin x equals to t. Let me see if that helps. If I do sin square x plus cos square x, and over here uh, 8 by 3 x, this becomes if we split the terms, it becomes 6 minus 2 by 3 minus 2 by 3 and cos minus 4 by 3 dx plus this one becomes cos 6 2 by 3 x sine minus 8 by 3 dx. Is this helping us? Now, okay. sin x. Okay, so let this be 1 and let this be 2. So let's solve them individually. We have 1 equals to sine minus 2 by 3 x cos dx. Sine 2x cos square x cos x square x. Should we simplify it further, or should we now substitute sin x or cos x as t? If we substitute cos x equals to t, we get sin x dx equals to dt. Sin x dx. Cos x minus 2 by 3 is power square. So this is basically sine to the power 2 by 3x and cos x, this is square, minus 1. Sin x into minus sin x minus 1. Let's substitute, see what happens. Equals to t. This implies minus sin x dx equals to dt. So I1 becomes, if we from the sine to the power minus 2 by 3x, if we bring out sin x, then what remains? 1 minus what remains? Minus 2 by 3 minus 1, minus 2 by 3 minus 1, minus 5 by 3, this, and we have cos this thing. Now we can do the substitution and we get sin x dx. We can replace sin x dx with minus dt, and no, it's becoming very complicated. Cos x becomes t to the power minus 4 by 3 and sin x to the power minus 5 by 3. Sin x to the power minus 5 by 3. No, I think it's getting unnecessarily complicated. We have to simplify it in a more smarter way. This is 12 Okay, I'm leaving it for the time. Next, with the next problem, I will come back to this problem later on. I'm leaving sufficient spaces. 3, 4. Let's do 5 over here. What is 5? Okay, the 5 integral is dx by root over 1 minus e to the power 2x. Now, a standard method, whenever there is an integral function with e to the power x or e to the power x or 2x, whatever, we substitute e to the power, that exponential term, as t, meaning let we the standard way is to let e to the power 2x equals to t. Now, this will imply e to the power twice e to the power 2x dx equals to dt. So this implies dx equals to dt by 2 to the power 2 into e to the power tx, which is dt by twice t. So therefore, if we do the substitution in the integral, we get I equals to dx is dt by 2t, and this 1 by root over uh, this becomes uh, this is this, and we have dt by 2t. Plus t. Okay, so this becomes we can to split it into factors in two terms, we can replace 1 with 1 minus t and plus t, and we over here have 2t 1 minus t dt. Now, if we now split the terms, we get root over 1 minus t by 2t dt plus, this is fine, this is easy, 2 gets cancelled out, and we have 1 minus t. This is easy. This integral is basically root over 1 minus t, minus of root over 1 minus t. But what about this integral? This integral t, I hope I did it right, to the power, if we have substituted 1 minus e to the power 2x equals to t, in that case, would it be a better choice if we have substituted 1 minus e to the power 2x equals to t? One minus, then this becomes 1 minus root t square to t. Let's see what happens. This one, for this one maybe we could okay, so this is let's say uh, okay, so this is no, let's say this is I1 and this is I2. I2 is easy. I2 will be what will be I2? Uh, Minus half root over 1 minus t. So the derivative of root over 1 minus t is 1 by 2 twice root over 1 minus t. Yeah, I hope this is right. I2 will be this. And I1, we need to solve I1. Maybe I am doing it in a very lengthy way and unnecessary complicated way, but let's do it anyway. Let's see if we get to the solution or not. Then later on we may try to do it in a better way. So one approach, one method we can possibly use is considering t as, let's say, cos theta. Then this becomes dt equals to minus sine theta d theta. Now this becomes root over 1 minus cos theta divided by 2 cos theta dt is minus sine theta d theta. Now this is 1 minus cos theta is 2 sine square, 2 sine square theta by 2, and we have theta by 2. 2 cos theta sin theta d theta. This becomes root 2 sin theta by 2 by cos theta sin theta d theta. Cos theta tan theta. We have having different angles, theta and theta by 2. Tan theta by 2, tan theta sin theta by 2, cos theta by 2. I'm not very strong in trigonometry, that is why I'm stuck. Let's see, I'll try another approach. Let's see what if we have substituted method 1 basically failed. Let's try method 2. Method 2. Let's say if we substitute if we substitute e to 1 minus e to the power 2x equals to t square, that we make the life more easier. Let's see. This implies minus 2 e to the power 2x equals to 2t dt. This implies dx. This implies dx equals dx equals minus t dt by e to the power 2x. Dx equals to minus t dt by e to the power 2x. This is minus t dt, and e to the power 2x is 1 minus t square. Okay, now the integral becomes 1 by t into dx is minus t dt by 1 minus t square, and this is minus integral of dt 1 minus t square. 1 minus t square. Okay. What we can do next? Will it help if we factorize the 1 minus t square as 1 minus t into 1 plus t, 1 minus t into 1 plus t dt, and in the numerator we write in terms of 1 minus t and 1 plus t 1 minus t plus 1 plus t, and we will get 2, so we divide by 2. So this becomes half integral of 1 by 1 plus t plus 1 minus t. No, what I'm doing. Plus 1 by 1 minus t. I hope this is now easy for dt 1 plus t, and we have minus half dt 1 minus t. So this is minus half log e mod of 1 plus t, and this will become plus half mod of 1 minus t and the constant of integration plus half. Okay, log e. I hope I am right. So now if we substitute back t is root over the 1 minus e to the power 2x. Now, so we can merge the two log terms and say half mod 1 minus t by 1 plus t plus c Now if we now substitute back uh, the t was root over 1 minus e to the power 2x. So this becomes this. Now the term inside the log, the argument to log perhaps can be simplified by using rationalization. We rationalize the numerator, the denominator, this thing, if we rationalize it, we will get 1 minus 1 minus square, and over here we get 1 minus e to the power 2x. This becomes what it becomes, 1 gets cancelled out, and this becomes 1 minus x. We can leave it here also. This is fine, but let me see if we further simplify the term inside the argument to log, if it becomes a little more simplified form or not. Minus 2 divided by e to the power 2x. This is equals e to the power 2x minus okay, so it is a little more compact form, so we could write the answer as mod this is the answer. Okay, so this was the last problem. I think the method 2 is a better approach. We can leave it here, and may skip the further simplification of the argument to log. This is fine. It will depend on what choices are given if it's a MCQ question. Now the one we couldn't do was the previous one with a, okay, this one, this one. What we can do, cosec x 1 by sine. If we sine square, cosec square, square x cos 4 cosec sine x to the power 4 by 3. We can do that, convert that to sine 2x. Sine into 3. Let me erase the solution first. Okay, now this thing 4/3. This is integral of dx by cos x to the power 4/3 and sin x to the power 8/3. Sin x to the power 4/3. It's 1/3. Okay, now so square x cot x square x square x. No, I think it is taking time for me to solve this. I will leave it. I will think about it later on and come up with a solution in the next video. So, sorry I failed to solve one problem. I hope this video was helpful and beneficial, and if it is, then please like this video and share this video with your friends, and please also support me by subscribing to my channel if you are not yet subscribed. And thanks for watching, and I will come up with more problems from the chapter integrals, uh, which will be based on more further standard results of integrals of indefinite integrals, which I will mention on the as a reference on the left hand side PDF, so that I can refer it as and when required. That's all for this video. Thanks for watching, and until the next video, take care and bye.